Hello everyone. In this video, let's discuss on a numerical problem related to how to calculate area from the given offsets from the field notes. Let's look into the problem statement. The following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meters 0, 2.5, 3.55, 4.6, 3.2 and 0 meters. Compute the area between the chain line, the irregular boundary line and the end offsets by using the first one, the mid-ordinate rule, second, the average ordinate rule, the third one is a trapezoidal rule, and the last one is using the Simpson's rule. The average ordinate method makes use of calculating the average of the ordinates given. We are supposed to calculate the mid-ordinate from the given offsets in the mid-ordinate rule. The trapezoidal rule and Simpson's rule have a pattern to be used, and they have their own advantages and limitations too. Let's look into the plot of the given data. So we have 0, 0, and then 2.5, 3.5, 5, 4.6, 3.2 and 0. So altogether we have about 1, 2, 3, 4, 5, 6, 7 offsets. The Simpson's rule is adopted for the odd number of offsets. So this is applicable to this problem also. Let's solve the mid-ordinate method of calculating area. Now the given offsets are 0, 2.5, 3.5, 5, 4.6, 3.2 and 0. We have to see how to calculate mid-ordinates. Now by considering 0 and 2.5, we have to calculate the average of these two things, in the sense an offset exactly at the mid of 0 and 2.5, which is 2.5 divided by 2, 1.25. Now for the next one, between 2.5 and 3.5, average of 2.5 and 3.5, which is about 3. Similarly, we are supposed to calculate all such mid-ordinates. Once we are done with the calculation of the mid-ordinates, the area is calculated by considering this 10. 10 is the interval actually between each and every offset which is given. The 10 is that interval. 10 into, we are supposed to add all these mid-ordinates. That's how we would end up with an area which is about 188 meter square. Right, the next one, by the average ordinate rule. This seems to be the one of the very simplest methods here. D is 10 meters and there are number of divisions. If we talk about the base length is 6, but number of ordinates are 7. So it is n minus. If you could consider the number of ordinates as n, you would always see n minus 1 the bases. So the base length is 10 into 6, which is about 60 meters. Right, now how do we calculate area? Again, it is 60 into some length. So this is the average of all the ordinates. So the average of all the ordinates, sum divided by number of the ordinates, and that's how we would end up with the area of about 161.14 meter square. Next is by using the trapezoidal rule. The interval is 10. Let's look into the diagram here. So you have a triangle on each of the extremities, and rest of all the other shapes are trapezoidal. But even then, the formula is written in a manner that the offset is 0 here, the offset is 0. Okay, so how do we do that? It is actually d by 2. D is 10 divided by 2 into the first offset plus the last offset divided by 2 could be done, or simply you can say d into first offset plus the last offset divided by 2, but that 2 is taken outside, so there is no divided by 2 here, but it is multiplied here. Now 10 by 2 into first offset 0, the last offset is also 0, plus 2 times the summation of rest of all the other intermediate offsets, 2.5, 3.5, 4.6, 3.2. So ultimately, whenever you try to consider the zero offset, the formula takes care of triangle shape here. So the required area solved is about 188 meter square. Let's look into the last method, which is by Simpson's rule. So now for the simplification, let's number the offsets. This zeroth one, 0 is the first one, second, third, fourth, fifth, sixth, and seventh one. So according to the Simpson's rule, it says d by 3 into the first one plus the last offset plus 4 times the summation of even offsets plus 2 times the summation of odd offsets. Now according to that, 10 divided by 3, 10 is d, plus the first one is 0, the last one is also 0, plus 4 times 2.5, and then 5 and 3.2. We are not considering again there are only these three values which are existing now, plus 2 times the odd values 3.5. We are not considering 1 and 7 because anyhow they are listed here. 3.5 and then the 4.6, 3.5 plus 4.6, and care must be taken while ensuring whether all the values are written or not. So if you can observe the values carefully, it is somehow all the values, all the 7 values are listed, and upon further simplification we end up with an area about 196.66 meter square. So what we could make out from all these calculations is one thing, we could see the variations in the final answers, variations owing to the consideration of curvatures. In some cases there would be a kind of a straight line which are drawn, and that's how we would be expecting some sense of accuracies and error between such kinds of calculations across all the types. Thank you.